All right, so this one is a challenging problem. Well, it's just a lot of pieces to put together, I should say. It's not necessarily hard, but the midpoints of the sides of a square of side length 1 are joined to form a new square. This procedure is repeated to form new squares as in the figure. Part A is we're supposed to find the sums of the areas of all the squares. Okay, so let's just start listing them off. Area of the first square is 1 times 1, so 1 squared plus. Now, if this is 1, then this is going to be a half, because those are midpoints. And this is going to be 1/2 times the square root of 2, because it's a 45, 45, 90 triangle. And then the area of this one is going to be, so that's square root of 2 over 2. Square root of 2 over 2 squared. Plus. Okay, so if we take half of the half, that's going to give us this distance here, which is square root of 2 over 4, half of square root of 2 over 2. And then this is going to be square root of 2 over 4 times the square root of 2. Now it's tempting to write that as 2/4, but I'm going to kind of leave it as square root of 2 over 2 squared? Right? I mean, it's the square root of 2 times the square root of 2 over 2 times 2, and then you need to square it. So we're trying to recognize a pattern here. As you can see, basically, to go from here to here, we're taking 1 and we're multiplying by the square root over, well, maybe I should just simplify these. I guess I'm seeing that you're multiplying each one by the square root of 2 over 2 squared, but I guess if we were to just actually simplify that, it would make more sense. So 1 plus, this is 2 over 4, which is a half, plus, so this is 2 over 4 squared, so that's 1/2 squared, which is 1/4. So I think you can kind of see the pattern here. 1 plus a half plus a 4th. Next one's going to be an 1/8. Should we check to see make sure it is an 1/8? This overall distance is 2 over 4, which is 1/2. That kind of looks about right. Does that look like that's about half of that? Half of a half is a 4th. So this is a 4th. And this is going to be square root of 2 over 4. And then we need to square that to get the area of the next one. Square root of 2 over 4 squared is 2 over 16, which is 1/8. Boom. So we kind of have the pattern. A little messy. I fumbled it a little bit, but we got it. So if we're going to add all those up, this is an infinite geometric series. The first term is 1. The common multiplier is a half. Therefore, the infinite sum is equal to 1 over 1 minus a half, which is 1 over 1/2, which is 2. All that work? The inside one is 2. All the other ones are just going to add up to 1, which you should have seen, because, you know, what does that sum? We talked about that series now a couple times. Walk halfway to the wall, walk half of the half, half of the half of the half. So that's 1, plus the initial 1 is a 2. All right, so I already got my things on here. Hopefully this will help me with part D, and I don't have to go through it all over again. B says find the sum of the perimeters of all the squares. So the first square is 4 times 1, because each one is 1. And then the next square has side lengths of root 2 over 2. So I need to take 4 times root 2 over 2 plus. The next ones were 1/2. So that's 4 times a half plus, and then the last, let's say the last one's for our check. So this is 4 plus, okay, so that's 2 root 2 plus 2 plus, so what's the pattern? Well, it looks like, so I'm not really seeing the pattern. Or what I want to say is, are we dividing by the square root of 2 each time? I can definitely see we're dividing by square root of 2 here, but I think we are here as well. If that's not as easy to see, you can take 2 root 2 and divide it by 4, and you get root 2 over 2, which is 1 over root 2. So we're dividing by root 2. And if I take 2 divided by 2 root 2, you get 1 over root 2. So it looks like I'm multiplying by 1 over root 2 each step along the way. So my R value is 1 over root 2. Let's see if it works on the next one. So the next one needs to be 2 divided by root 2. So this last side was square root of 2 over 4. And if I divide by the square root of 2, you get square root of 2 over 4 times 1 over root 2. Be 1/4. Dang it. All right, I'm sorry, I screwed that up, and a couple people came in and I got confused, and I do not want to do this video over. So to do this, to show that this last term is right, this distance is square root of 2 over 4, but the perimeter is 4 times square root of 2 over 4, which is square root of 2. Oh, crap, which is still not the right freaking answer. Okay, I'm going to finish this because I don't want to do it over, even though I'm fumbling it time and time again. So it is square root of 2. And this actually is square root of 2 also, because if you multiply by root 2 over root 2, you get 2 square root of 2 over 4 over 2, which is root 2. Okay. So, even though I fumbled this, I think I have the right stuff. The first term is 4, and the common multiplier is 1 over root 2. I'm sorry if this has been a little confusing, but so if I want to add them all up, put it in the formula. It's your initial term over 1 minus your R value. 1 over square root of 2. Now I got to clean this up. Square root of 2 minus 1 over square root of 2. 4 over 1 times square root of 2 over square root of 2 minus 1, which is 4 square root of 2 over square root of 2 minus 1. Then I need to multiply by the conjugate. Oh my goodness. Which is square root of 2 times square root of 2 is 2, times 4 is 8, plus 4 square root of 2 all over square root of 2 squared is 2 minus 1, which is 1, which is 8, plus 4 square root of 2. I hope that's the right answer.